Thanks for staying back. I understand it's a grueling day, lots of sessions, lots of technology stuff. Last two talks are left. I promise this session will be interesting. I have kept minimum PPTs, minimum slides, lots of code. It's going to be very simple code, things that will be directly understandable and things that you can go back and try right away. So to start with, how many of you are non-.NET developers here in this room? People who are from J2E or any other background? Few hands there, couple of people here. And how many of you have not heard about LINQ yet? LINQ. Okay. So for the remaining people who are .NET developers and already have heard about LINQ, I'll try and make this session wherein I can answer your questions and doubts. Unfortunately, we don't have too much time, so keep those questions towards the end. I'll try and finish it up quickly and then take the Q&As. To get directly to the session, I'm going to cover three things: language enhancements, LINQ, and then LINQ-enabled data sources. I'll explain what is the difference in each of these three things as we go ahead. The very first question that comes to mind is, what is LINQ and why do we need LINQ, or why do we need something new first of all? So, what do you think could be the reason behind enhancing a language or introducing new features or functionality in a language? Essentially, as developers, you want to be more and more productive. You want to write less and achieve more. You want to do things that are simpler. You want to write code that is easy to read, easy to understand, easy to manage and maintain. These requirements actually propel the need for creating something like LINQ or language integrated query. What is language integrated query? It's pretty much the capability to write SQL kind of queries within your programming language. The ability to query any kind of data, not just SQL data, not just databases, but in fact, in-memory data that could be coming from any other source, let's say a file system, let's say XML. Keeping a unified mechanism to query any kind of data, that is the key driving force behind something called LINQ. There are other lots of things, like as you combine LINQ with Visual Studio, you get the IntelliSense and the compiler checking capabilities, which are again add-ons, but they have nothing essentially to do with LINQ per se. Obviously, LINQ also gives you the benefit of implementing very complex logic within your applications using very simple code. We'll see all these things as we move towards this session. There's one thing that I wanted to remind you of, that LINQ today is relevant for C# 3.0 and VB.NET 9.0. It is not available for VC++, so if there are any native developers or VC++ developers, you will be disappointed. But still, I would encourage you to listen to what I'm going to say, because that's something that's not available in VC++, and you can think about interesting scenarios around that. One more thing here is, LINQ is a part of the .NET Framework 3.5. So one single most biggest enhancement in .NET Framework 3.5 is LINQ, L-I-N-Q. The first thing, new language features or new language enhancements. What do we mean by these? So here is a list of about 8 or 9 language enhancements, features that have been implemented or introduced in C# 3.0 and VB.NET 9.0. Let's forget about talking. Let's directly look at all these things inside the code. Just to be able to talk about everything, I have put down code here, and I will show you all these features one by one. Code is going to be pretty simple. Just to make sure, everybody on the last bench, can you see the code? Yes? Great. So let's look at this piece of code. I'm just declaring some variables here. Integers, strings, boolean, a custom class which is defined here, which is nothing but 2 integers, that's it. Now, pretty simple code, nothing fancy here. I'm going to make some changes in this code in front of you. Some syntactical changes. What have I done here? I have removed all the data type definitions, integer, boolean, string, and so on and so forth, and replaced them with something called var. What do you think is var? Let me just build this code to show that. Forget about the output, it's not really very relevant here. The point here is, no matter what the data type is, when I'm using var instead of the data type name, I'm still able to declare or define a variable. All of you must be remembering JavaScript or VB for that matter, which has something called var, which is like a variant data type or a dynamically changeable type or dynamic types as we call them short. What is var in terms of C# 3.0 and VB.NET 9.0? var is local variable type inference. It's a keyword that tells the compiler that I don't know the type, go and figure out the type yourself based on whatever is on the right hand side. So the compiler here, whenever it encounters this keyword var, sees what's on the right hand side and figures out the type of the right hand side and declares this variable I or S or whatever it is based on the type of the right hand side. Now, the first question that will come to your mind is, does that mean that C# is no longer a strongly typed language? Does that mean that I can now change the type of the variable on the next line? Let's say if I want to do something like I is equal to hello, can I do this? What do you think? No. C# is still a strongly typed language. If I try to compile this, it will give me an error. It says that I cannot convert an integer to string, which means that the compiler has already allocated I as an integer, and once the type is determined, you cannot change the type. It is strongly typed. The question is, why do we need this then? What is the advantage of something called var? Why can't I just declare integer, string, so on and so forth, and carry on with my application? Keep this question in mind. I'll open this suspense up in a while. But this is local variable type inference. The next thing is object initializers. Let's look at this simple code. Do you see something new or different in this piece of code? What's different here? The curly braces, right? Normally, whenever we create a class or an object of a class, what do? Or for that matter, in the new line, I would say obj.a is equal to or obj.b is equal to something, right? Now, what am I doing in this particular case? What's this something new? This is called object initializers. This again is a new syntax available in C# 3.0, which allows me to actually initialize the object the moment I'm creating it. Okay? So in this particular class, I have two member variables A and B. What I chose to do here was, okay, A is equal to 10. It goes and creates that object and initializes the member variable A with the value 10. I could also do B is equal to 100 at the same time. Or for that matter, remove A, just initialize B, or A in any order. Okay, as long as I am initializing any member variable, I don't need to worry about the order or whether it is one or all or none. These are known as object initializers. Okay, fairly simple. The question is, why do I need this? What is the advantage? What benefits do I get out of this? Let's keep that question in our minds for a little while now. And let's look at the next feature, anonymous types. Again, very simple, one single line of code. Very similar to what I did in the previous feature where I showed object initializers. Now, what does this line of code look like? Or let's talk about what do you think is wrong or possibly not so intuitive in this particular line of code. Type. I'm not defining the type. I'm not specifying the type. What is the type that I want to create? Okay, I said fine, create a new object, but of what type? I am not defining anything here. So what does this mean? Can I now create types which no longer have any definition? Yes, C# 3.0 and VB.NET 9.0 allow you to create objects that have no predefined type. These are known as anonymous types. The advantage. There is one straight away, like a straightforward advantage of this thing. What do you think is the advantage of this particular feature? I do not need a type. I can group pieces of information or pieces of data into an object and create it on the fly whenever I want, wherever I want. I just do a new and say, okay, A is equal to 10, B is equal to 100, or say for that matter, C is equal to hello. The compiler understands this. So what's happening in this case? Var, which I told a little bit earlier, is a directive to the compiler that go to the right hand side and figure out the type from the right hand side. On the right hand side, we do not have a type here. What it does is, it just allocates some memory, creates these 3 member variables in that memory location, figures out the type of each of these member variables based on the initializing value, and defines them there and there, and points this V to that memory location. Now you have anonymous types, a type which does not have any definition in your code earlier. Again, very obvious question. Fine, wonderful, but what is the advantage or what is the use? Where am I going to use all these things? Sorry? Great. Okay, sorry, I didn't show that to you. Let me show that right away. Now, on the very next line, if I go and do something like this, v dot, I actually get all the member variables that I have defined. So they are still accessible for me. It is a complete type which has 3 member variables A, B, and C, whose types are already predetermined based on the initializer or the initialized value. Okay, so it's a complete object that you can use like any other object. Okay, let's look at the next thing, extension methods. Before I show that, let me show you a piece of code here. What I've done here is I have defined a public static class, and inside that class I have defined a static method which is returning nothing, void in this case, and the argument here for this method is a little bit strange. Typically you would be used to seeing something like this, right, which takes a string parameter. Now I'm adding a keyword this here. What does this mean? The keyword this tells the compiler that this particular static method needs to be applied to any type which is defined here. So this particular method will be applied to any string type. Now let's see what do I mean by being applied to any particular type. So I go here, I have a string which I have defined, and the moment I do a dot here on this, what do I see? I see the function that I defined inside that static class, that static method, available as a method of strings. If you had to do something of this kind today without using C# 3.0, what would you do? Extend the class, derive from it, and create an instance of the derived class by adding methods into the derived class. What have I done just now? Without using a derived class, I have been able to add methods to an existing class. This is string. It could have been any class. It could have been integer. It could have been your custom class. Let's see how I can change this to be applicable to integers. Just this. Now on the next line, if I go and do something like int my int, let's say initializing it, my int dot, I get this function, my function, now for integers. What if I want to pass parameters to this? Comma, let's say string st. Now when I do a dot here and choose my func, you'll actually see that the second parameter or the second argument now becomes a parameter to this function, my func. So the first argument specifies to which kind of type will this method be applied, and Going beyond, you can specify as many parameters or as many arguments you want for that particular function. Now question, does that mean that I can override the existing base class methods? Yes and no. You cannot override in the true sense, because overriding means the same number of parameters, in which case the base class methods will take preference and you won't see the extension methods available here. But if you change the number of arguments, or if you change the number of or the type of arguments, then yes, you can change the or override the base class method definition also. So as long as there is no ambiguity, you can use extension methods to change the functionality of the existing types. Something interesting, you can in fact add this method to object. Now this method is available for any type inside your C# application, because this is going to be for objects. One more thing to remember here is this is a separate class. It can be enclosed within a namespace, and you can include that namespace in any part of your application and call these methods on the types that are defined for the extension methods. So typically, if you look at any of the developers today, they have their pet pieces of code which they copy paste, or they put into a separate class and instantiate that class and then call those methods, passing specific arguments into those methods to do those things. Say for example, conversions, date time conversions, or Unicode conversions, or some pet pieces of code, simple code but which you use very frequently. Now what you can do is you can put them into a static class, define them as extension methods, enclose them inside a namespace, include that namespace anywhere you want, and those methods would be available for any of the types that are predefined or you are using within your extension methods. Does this sound interesting? What do you think as a developer? Is it something that, specifically let's talk about extension methods. Does it seem useful? Will your effort be reduced? Sorry? No, if you have a sealed concept, if you have a sealed class, then you cannot add extension methods to it. So if you have, the sealed concept is still intact. We do not touch the sealed concept. And these methods do not change the structure of the class. So if you look at it, how it happens, it is happening at the compilation time. The compiler actually creates an internal table, puts all these static methods inside that table, and says these methods are going to be applied to this particular type. So whenever I go to that type and try to instantiate or do a dot on that type, apart from looking at the base class, it also looks into this table, picks up all these methods from this table, and just makes a pointer which will point to these methods inside this table. So it is not changing your base class at all. It is adding these methods at the compilation stage into your objects that are created. So, yeah. No. So that's the beauty here. The MSIL has not changed. The MSIL is still exactly the same. What's going to happen is your code is regular object is created, and that object gets another, let's say, a pointer, which is pointing to this method which resides in this table that is maintained by the compiler. And once that is done, at the runtime, it's available for you as a new method in that particular object. Your class is not changed. So this, okay, I didn't want to use the word syntactic sugarcoating, but yes, if you as a developer want to look at it, it's happening at the compilation stage. It's the compiler that does all this syntactic manipulation for you and gives you these benefits as a developer. So you have to write less, and you can achieve much more using these features than you would have done without them.
So at the CLR level, no changes will be?
No, no. It's the IL that changes. Okay.
Which are members of the base class can be accessed in the extension method? Protected members?
I didn't get you. So, okay, so if you're talking about the base class and it has private member variables and things like that, no, you don't get access to those methods here or those member variables here, because the, sorry? Not even protected, not even public. Public obviously yes, but you'll have to use the complete namescope resolution. Because these are added methods, your class doesn't even know about these methods, or these methods do not know anything about the class for that matter. They are defined separately inside a static class. Okay, the next thing, auto-implemented properties. So earlier, if you remember, whenever you are defining properties or you are defining member variables, you have a big class which has lots of properties. You have to typically create getters and setters for that. Now, getters and setters, the code is very mundane. It's just repetitive code, except for the fact that the member, the argument changes. The name of the argument changes or the type changes. Now, in C# 3.0, what we have done is we have implemented created auto-implemented properties which allow you to create a getter and setter without having to create or write the code or that member variable yourself. So the compiler will create an anonymous type, arbitrary variable, and put it inside your IL code for you rather than you having to do it yourself based on the type again. So fairly simple again. Yes, the question is, what is the advantage? What do I get out of this? Why should I use this? We'll come to those things in a while. The next thing is lambdas or lambda expressions. So how many of you have used any functional programming languages like Perl or Python or TCL/TK or any of the functional programming languages? So lambdas or functional programming languages have lots of cool syntaxes which look a little complicated but give a lot of flexibility, a lot of power to the developer to write code in a simplistic or a minimal form. Lambdas are one of them. They're very prevalent in functional programming languages, and now as a C# developer you can get benefit or get these kind of benefits in your programming language, even for VB.NET programmers. So if you look at this highlighted portion of code, it is read as x goes into x times. Okay, so if you look at this piece of code, there is no type definition here at all. What I've just done is x goes to x into x. What does this mean for a compiler? The compiler says, okay, there is a construct, there is an expression, which means that no matter what the type is, as long as I can do this kind of an operation, as long as I can multiply these two types, I will take it and do this operation and return that type. If I have to create this is called a lambda expression, to be very precise or very specific. If I have to create a lambda expression with two member variables, what I'll do is, I'll do xy and x goes into y. That's it. So now I have a lambda expression which takes two parameters, multiplies them and returns me a value. Where can I use lambda expressions? What is the purpose that lambda expressions serve? So let's go back into anonymous methods, C# 2.0, or delegates. What is the advantage of delegates? You can create a signature, and then as long as the signatures match, you can attach that delegate to any function that has the same signature, right? Lambdas are an evolution of anonymous types or delegates. The added advantage here is you don't even have to worry about the type. So if you remember, in delegates, the types should match, the signatures should match. Here, I'm not even declaring a type. So virtually what that means is I can use this particular lambda expression anywhere without worrying about the type. And that's exactly what I'm going to do here. So if you look at this construct, C# 3.0 gives you something like func, which comes from the system.link namespace. I'll talk about these things a little later. And I'm going to create a function which takes one parameter and returns another. So both are going to be integers. I'm declaring it as my func. And now what I have done is I have equated this particular function to a lambda expression. Okay. What is this function? This is known as a generic delegate. Okay, so it is an encapsulation over the delegate functionality which allows you to create generic delegates and assign a lambda expression to any of these delegates at runtime. How can I use these? So a very simple example. What I'm doing here is I'm just calling my func with a parameter 5. What this does is it substitutes x as integer, says that I am going to get the value of x from this particular expression, which is x into x. This could have been anything. It's not essential that I have to use x. I can use y. here, y. So these are variables whose type is determined by the compiler at the compilation time based on the way I'm using it. Because in this case I'm going to use it as an integer, it declares it as an integer. Again, fine, quite nice. Where is the practical implementation or the practical use of these constructs? Just hold on for 2 more minutes. Let me show you this last thing and then we'll come to the interesting part. What I'm doing here is I am creating an expression. So this is a new class that's available in the system.link namespace. I'll tell you about the namespaces in a while. For now, just remember that there is a new namespace called system.link which gives you all these capabilities. And I have just created a lambda expression. Now in this particular case, my lambda expression is manipulating some strings. So it's taking a string x and adding it to the pre-existing string or the predefined string hello world. What I'm doing here is, okay, I've created a generic delegate just like in the previous case, and this generic delegate is now pointing or getting the value from the lambda expression that I've defined in the previous line. How? By calling a compile statement on it. So lambda expressions can be used within an expression tree or an expression object. What does a lambda expression the expression tree or an expression object contain? It contains code in form of data. So if you put a breakpoint here, let me do that, and if I come to this particular line, let's see what's going to be inside the statement. So this just contains the expression as it is. It does not contain the computed value. If you look at what's here, it has the expression as it is. I have not changed anything. The compiler has not changed anything. The compiler has just taken this expression and put it inside the lambda expression. What I'm doing here is, when I call compile, that's when this data gets actually converted into a delegate. That's when it becomes usable. So this gives you kind of a lazy load or a lazy evaluation technique wherein you can create expression trees, keep them as data and compile them only when you need them or when you want to use them. Lots of interesting things that can be done with this. Unfortunately, I cannot cover everything here, but I'm sure you will find it interesting and start using them. Okay, so I showed you some of these language enhancements. Okay. First of all, let me just go back to the first slide that I had here. And if you remember, I have 3 points here. Up till now, whatever I have spoken is or applies only to the first point, which is language enhancements. Why have all these language enhancements been done? Why have these features been added to your programming languages? What do you get out of them as a developer? That's when LINQ or language integrated query comes into the picture. Now let's see a very simple example of LINQ. So small piece of code, just 3 statements. The first statement is self-explanatory, a string array. And the third statement again is self-explanatory. I'm just iterating through the array. Let's look at this second statement. This is something which may sound unusual, unfamiliar to C# developers till now. What do you think I'm trying to do in this particular statement? What does it look like? Query. I am trying to run a query on what? Names. Okay, which is a string array, which means it's an in-memory data. So first thing, the reason I always prefer to show this example is because whenever the word query comes into the mind, the thing that first we relate to is databases. Queries run on databases. LINQ is not about databases. LINQ is about the ability to query any kind of data, no matter where is it coming from. It could be coming from XML, it could be coming from in-memory source, it could be coming from your file system for that matter. For LINQ, data source is hardly a issue. Now, what's happening in this statement? From n in names, select n. Okay, let's put a breakpoint here and just run this code. Okay, this is not what I need. So first of all, if you look at EXP, what is EXP at this point? It is a collection of something. Okay, let's forget that something for now and let's go ahead. This is when the expression actually gets evaluated. So two things, if you look at expression trees that I just showed you, they were using something called lazy evaluation. They just keep the code as data, and only when you start using it does it become or does it get executed. That's what is happening in case of expression here also. So this is nothing but what? Expression tree or an expression, right? Where is it getting the value from? From the right hand side. So the very first thing, local variable type inference. That didn't really make a lot of sense when I said where I is equal to 10, where S is equal to hello, where B is equal to true. Because you could have written the same thing, integer, string, boolean. What is the advantage? But now when I start working with complex data, when I do not know what is going to be on the right hand side, that's when the real benefit of where comes into the picture. Now the compiler, as a developer, I do not have to worry about what is going to be the type of data. The compiler goes and figures it out for me. In this particular case, because names is a string, I get a collection of strings in var. Another thing, what I mentioned earlier was complete IntelliSense. So look at n. When I do a dot here, n being a string, the methods that I can see here are the ones that apply to a string. Let's do something tricky here. So let me copy this, let me put it here, and I will make this as int, comment this out, and just put some values. I am not changing anything in my LINQ statement. The LINQ statement remains as it is. Still compiles. Now n is an integer for the compiler. It no longer cares about string. Just to give you another idea, now when you do a dot on n, the member functions or the methods that you get are the ones that apply to integer types. Imagine this to be something else now. XML, n could be XML, n could be a SQL table, n could be a record set, n could be a data set. A list of files or a file system object, anything for that matter. Now, the query that you're running on depends or is agnostic to the data type, just depends upon the compiler to figure it out what's going to be the data type. So fine, so far so good. Let's look at the real power of query. So let's try and order it. From n in names, order by n ascending, select n. Let's do something more here, where n is less than 7. Just to show you that I'm not bluffing here, let me show you the output. So forget the first two lines, they are outputs from the previous portions of the code. Here what I'm getting is 4 and 5. So what have I done just now? I have been able to run a query on in-memory data. The query can be as complex as you want. You can have order bys, group bys, joins, where clauses, anything for that matter that is available in a simple SQL query, and run it on any type of data. In this particular example, we have in-memory data, which is a string array or an integer array, and I can run this here. One thing to remember is LINQ queries. Okay, so this is LINQ. This is the simplest example for LINQ. I'll give you some resources towards the end where you can find out more examples or more complex things that you can do with LINQ. What is the advantage, or what do you think is the benefit a developer gets with LINQ? Can somebody name something? Sorry? Querying XML data. You don't even have to worry about the type of data. Now, today, if you want to query XML data, you have to know either XPath or XQuery. You have to understand those languages, right? If you have to query in-memory data, you need to know the programming language. You have to use for, while loops, constructs, like that. If you have to query SQL data, you have to know SQL. So the moment the type of data changes, the query language for that data changes. In this particular case, no matter what kind of data source the data is coming from, you can actually run the same query on top of that data. Yeah. And IL code is generated for them. So if you look at the IL code of this particular application, it will be complete in itself. It will not have a function call for from, where, or anything that sort. So the IL code is generated by the compiler for this particular construct and put into your assembly or your PE file for that matter. And what this means is there is no runtime implication. Okay, you could have written the same thing in form of a for while loop, for loop or a while loop or for each statement. Nobody is stopping you from that. The advantage you get with LINQ is because LINQ or the compiler is able to understand your code much better than what you know. It is able to optimize or apply optimizations to your code, and the IL that is generated by the compiler for a LINQ statement is going to be invariably more optimized and much better than what you could have written in form of a for loop or a while loop. Okay, so are there any questions so far? Let me take two quick questions. Okay, three questions, quick questions here, so that I. Yes, exactly. So what you can actually do here is you can use joins. You can join the different types of data sources and create a complex data source which will give you data values from, let's say, string and integer, and you can run a query on top of it. Another interesting thing that comes here is, so if you see, because this is completely addressable for me, I can actually call methods. If this is a complex type, let's say if it is a custom type, if it has methods, I can call those methods inside a where clause and do complex calculations or complex business logic stuff right there inside my LINQ query. Yes, the second question. Yes.
So instead of names, can I actually target an order table or a sequence?
I will just show you that in a while. Give me 2 minutes and I'll come to that. Yes. So as I mentioned earlier, in this particular case, everything happens at the compilation time. So the compiler actually takes your LINQ query and generates the equivalent IL code for that particular query and puts it into your assembly or your PE file. So there is no runtime performance implication. No late binding. In fact, you will get performance boost at runtime because the compiler is most likely to optimize the code that is being generated. Having said that, there is definitely a little bit extra compilation stage, like compilation performance that is required. But nobody cares about the compilation performance because look at the benefits you are getting out of it. That's. Just give me 2 minutes, I'm coming to the SQL part. Let's just talk about LINQ right now. Okay. If you remember, there were 3 things in my slide: language enhancements, LINQ, and LINQ enabled data sources. So LINQ enabled data sources touch the SQL thing. I'll just come to that in a while. One last question. Actually, the gentleman there has been raising the hand, so I'll come to that. I won't drop your question, I'll take it later. Okay. Obviously, so compilers optimize your code, right? Sorry? Let's take it up offline. If you can show me a code snippet which you have written is better than the LINQ query, I will believe it. Okay? Yeah, we'll take it offline. I will take your questions after because I won't be able to finish my session if I take too many questions right now. I will be available here so we can take on as many questions as you have. I know this is interesting, lots of questions come into the mind. Now, this was about LINQ. Let me again go back to my first slide. I showed you 2 things up till now: language enhancements, which are the new features, all those things, extension methods, anonymous types, local variable type inference, all those things. Then I showed you LINQ. how LINQ is built on top of these language enhancements. So we had a question like, why do we need those language enhancements? Now is it clear why were those language enhancements introduced in C# 3.0 and VB.NET 9.0? No? LINQ is built on top of each of these language enhancements. LINQ makes use of these language enhancements. So to create LINQ, these language features were introduced. You can use these language features inside your application without even touching LINQ or without making use of LINQ. Say for example, extension methods. You're free to use those features because they are available at the compiler level. They have nothing to do with LINQ. If you want to use LINQ, that's when you use the namespace, which is system.data and system.xml.link. What is the, what's the namespace that you need to add? System.link. So whenever you create a project in Visual Studio 2008 using .NET Framework 3.5, it is by default included. You don't have to add or write anything separately. Now, coming to the last thing, LINQ enabled data sources. I'm going to leave all this stuff as it is, and probably I may have to comment it out later on. But before that, so I'm going to add a new item to this particular application. What is this item? It's linked to SQL classes. So this is something new in .NET Framework 3.5 and specifically Visual Studio 2008. When I'm going to add this, Visual Studio actually creates a DBML file and some code behind file, a C# file, automatically for me. Let's look at the C# file. It is auto-generated code. Right now, not much of it is there. Okay. Let's go back to the DBML. Let me look at the Server Explorer. I have a test database here, which is SQL Express. I don't have SQL running on my box. Unfortunately, laptops are not the best to run SQL. So I have SQL Express and I have a test database which has some simple tables, an order details table and an orders table. All I've done is I've dragged and dropped these tables onto the DBML designer, and if you look at the C# file now, you'll actually see that a lot of code has been automatically created for you. So first of all, I get a data context. Okay. So this is the database that I'm using. Some mapping is stored somewhere. The mapping source currently is defined here. Apart from that, some methods are generated automatically for me. Insert, order detail, update, delete, insert, all these things. Let's look at the table definitions. So here are the tables: order details and order. These are the two tables that I added into my into my application. This is auto-generated code. I don't need to touch it. I'm not worried about it. Now what I'm going to do here is, that's a data context. Let me create now. What do you think I have to do here? My data context and what? The moment I do a dot here, I get all the tables, all the methods that are possible or accessible for me. Order details, select, n, simple query. The source is now what? SQL. Rather than being okay, let me just do the regular copy paste stuff. So now when I do a dot here, I actually get all the fields that are available in that particular table or in the resultant query. So let's say I am worried about order ID. Okay, here I go. Let me put a breakpoint here. This is not needed. Okay. So if you see the last three values, 3, 4, 7, they are now actually coming from where? From the SQL Express database. What have I done? I have run a LINQ query on top of a SQL database right now. I can go as complex as I want in this particular query. Let's say where n dot order id is greater than 3. Okay. Now, what do you think? 4 and 7. I don't get 3 now, right? I can do a order by here if I want. There you go. Or because that's already in ascending, let's say descending. Okay, now coming to the questions that you had about stored procedures. Okay, what happens to my stored procedures? Can I use my stored procedures here? Yes. One, you can call your stored procedures here because the data context is actually capsule or a wrapper around your entire database schema that you have pulled into your application. 2, you can do a lot of stuff inside your application which otherwise would have been done in stored procedure. So the next question is, does that mean I should not be using stored procedures anymore and be implementing all this logic inside LINQ? No. The choice of where you want to use LINQ still depends upon your architecture. So let's say if you have a multi-tier application where you have a data access layer, a data manipulation layer, and a data presentation layer, you can use LINQ anywhere you want because as long as you can write C# code and you're using .NET Framework 3.5, LINQ is available to you or accessible to you. Where is it going to be most beneficial? That depends upon your architecture. So if you are going to do a lot of data access, just running a stored procedure to get data into your manipulation layer or presentation layer, then probably running a stored procedure will be best because stored procedures are optimized for databases and they run much better when dealing with the database. But if you are going to be doing a lot of manipulation on some selected or filtered data, then LINQ is going to be very, very powerful because then you can run a quick query, write a small logic inside your manipulation layer, or for that matter, even in your presentation layer. You can bind a LINQ data source to some, let's say a data grid or data view or something of that kind, and then automatically get the data into the presentation layer. Having said that, the choice of LINQ is first and foremost for developers. How productive are developers going to be writing that specific layer? If developers save a lot of time writing that logic and the performance drop, let's say in case of data access, is minimal, then you still have a case where you can use LINQ. If you hit upon or if you run into issues wherein LINQ is lowering down the performance, the best thing what we would recommend at this point is, first, develop your application as much as possible on LINQ because the amount of time or effort spent in writing LINQ code is minimal. Then when you profile your application and you hit upon roadblocks and say, okay, when I try to do this particular thing with LINQ, I'm getting less performance vis-a-vis if I run a SQL statement directly or call a stored procedure, replace that particular snippet with direct access to your SQL stored procedures or SQL code. That's the most productive way. But that's not again a silver line or a silver bullet. You may run into issues or you may run into scenarios wherein LINQ is going to give you huge benefits At the same time, there may be scenarios where LINQ is not the best choice. So based on your architecture, try to figure out where does it fit the best. It's definitely going to be very productive wherein you are writing a lot of manipulation code or presentation code, because that's where developers can write one single statement and achieve a lot of stuff in that one query. Okay, any questions? I have a few more slides. Let's go through those slides quickly, and then I'll take questions. So the first thing is, what are the advantages of LINQ? It's quite evident. Write less code, achieve more, do a lot of stuff in minimal amount of time with minimal code. If you have little code or less code, maintenance or code management also becomes much more simpler. You don't have to debug a lot of those things. And since all of this is happening at the compiler end, you can expect compiler improvements to directly benefit or directly give performance benefits to your code. It's completely SQL enabled, so you can have joins, you can have where clauses, you can have groupings, you can have orders, all those things. You can work with any kind of data, not only relational, but it could be hierarchical or it could be object-oriented data. The SQL query doesn't really care about what kind of data you are dealing with. Finally, it is an extensible API, so you can actually extend LINQ. The example that I showed you on SQL Express is actually a demonstration of how LINQ can be extended and taken to SQL. So LINQ to SQL is the extension of LINQ for SQL databases. When you install Visual Studio 2008 or when you install .NET Framework 3.5, you actually get 4 data adapters by default: LINQ to objects, LINQ to datasets, LINQ to XML, and LINQ to SQL. If you have to, let's say, work with SharePoint, let's take an example of SharePoint. If you want to run a LINQ query on SharePoint portals or SharePoint servers, what do you think you'll need? Sorry? You'll need to write an adapter that will give you LINQ to SharePoint kind of a functionality. What this adapter will do, it will connect to the SharePoint portal or to the SharePoint website and give you a IEnumerable interface on top of which you can run a LINQ query. As simple as that. And if you are interested in finding out how can I write such adapters, LINQ to SharePoint incidentally is already available on Codeplex. So www.codeplex.com, go there and search for LINQ to SharePoint. It's an open source community initiative, so that will give you an idea about how you can create your own adapters. And this could be for BizTalk, this could be for file system. So let's say if I were to give you a task, create a LINQ to file system adapter which will allow you to run LINQ queries on your file system objects and figure out how many files have changed since yesterday, how many files have been deleted since yesterday, or how many files have a particular size range. By writing a LINQ query, what would that query look like? From n in, instead of XML or SQL, now it will be your file system object. Select n, or where n dot creation time is equal to or greater than something, select n. As simple as that. Programmers no longer need to understand multiple query languages for different types of databases or data sources. As long as you know LINQ, as long as you have a link to something provider available, you can run a LINQ query on top of it. So remember I showed you the data context here. This data context, it actually derives from a base class called DataContext. So if you go into this base class, you'll actually see that it does all the connection handling for you. So that connection part is automatically generated and created in this LINQ to SQL layer for you. And you just run queries or LINQ queries on top of objects that represent your classes, your views, your stored procedures, or fields and parameters inside your table. Does that answer your question? Okay, great. That was the 5th thing that I wanted to tell you. So I told you 4 data adapters: LINQ to objects, LINQ to datasets, LINQ to SQL, and LINQ to XML. Now, what if I want to run LINQ queries on Oracle databases? Or what if I want to run LINQ queries on top of DB2 or something else? What are the options I have today? We have something called LINQ to Entities that is still in CTP, which is slated to be released sometime later this year, which will allow you to run LINQ queries on top of any data source that has ADO.NET provider. So as long as you have an ADO.NET provider, let's say for Oracle or for DB2, you can run LINQ queries on top of that. The question that would come into your minds is, okay, that means I can use LINQ to Entities to run a LINQ query on SQL also, because there is an ADO.NET connector for SQL also. So then why do you have LINQ to SQL? This actually, there is some story behind this, because at Microsoft we have two different teams, the ADO.NET team and the SQL team. Both of these teams started using LINQ independently and came up with LINQ to SQL from the SQL team and LINQ to Entities from the ADO.NET team. There's a huge overlap. Today, the directive or the suggestion is, if you are going to use LINQ on top of SQL only, use LINQ to SQL, because it is optimized for SQL. It will give you huge performance boosts and benefits. If you don't know what kind of a data source you will be running into, then use the ADO.NET or the LINQ to Entities provider. In future, it is very much possible that these two merge and become one. As of now, they are different and they have different applications or pros and cons. Yes?
Question regarding your that object initializer. So you said you can, if you can go open the code.
Yeah, sure.
One of the first things that you
Yes. This one?
Yeah. So in there, if I don't want to, this is like totally exposing the internal implementation of the class, right? So if I don't want some of my fields to be initialized from outside, how would I do that?
You keep them private, they won't be accessible
So
yet.
these are all public.
Yes, public member fields. No object-oriented paradigm has been touched or changed. All object-oriented concepts still apply as it is. These are compiler modifications to make developers more productive. Yes?
Very many implementations it says where I is equal to 10, right? What if I meant the 10
Okay, so anything. As long as it is implicitly convertible, you can do that without any issues. So let's say if I were to use 10.8 here, fine, because the compiler can figure out that it is a float. So I need to declare a float.
What if it is 10, but I want it as a long int?
You can do conversion, explicit conversions. So var will be exactly the type which is on the right hand side. If you have declared 10, it will be an integer. Now if you want to convert that integer into a float or into a double, then you'll have to explicitly convert it. So that's how we are used to thinking. If you say float f is equal to 10, it's still a float, right? But if you write int f is equal to 10, then it's an integer because you're explicitly defining it. Now in case of a local variable type inference, what happens is the compiler sees what is on the right hand side. Because integers have higher priority than float, it first allocates an integer, it's onto the, because that's what it understands. People are leaving, so let me quickly just run through these slides. I've already spoken about all the stuff here. Understanding a LINQ query. So as I mentioned, you can have complete query operators, select, where, order by. What are the advantages of using LINQ? You can run a LINQ query on top of any kind of data source. It could be relational, hierarchical, it could be coming from SQL, in-memory data, XML, or for that matter, file systems. We don't really care about it. It's available in VB and C#, and it has support for static type and dynamic type languages. How is it done? It makes use of all the language enhancements that are available in C# 3.0 and VB.NET 9.0, which is lambda expressions, anonymous methods, implicit type variables, extension methods, expression trees, query expressions, lazy evaluation. Each of these topics is a huge topic in itself. If you want to really delve deep into what are lambda expressions, just go to the MSDN website, search for lambda expressions. You'll get a lot of documentation that will give you more in-depth details on these things. You can use LINQ on top of .NET 1.0, 1.1, 2.0 objects also. What this means is you cannot use LINQ in a .NET 1.1 application, but if you have a .NET 1.1 assembly and you are creating an object in your .NET 3.5 application for that particular assembly, then you can create or you can run LINQ queries on top of it. You can use LINQ and achieve the create, retrieve, update, delete functionality also. For LINQ to SQL, it's automatically implemented for you. If you want to do that for your in-memory objects, then you'll have to write some code to achieve that using regular language syntax. Already mentioned, LINQ can be extended. LINQ to SQL, LINQ to datasets, LINQ to objects, LINQ to XML. These are the 4 adapters that are available by default. LINQ to entities is also available, but right now it is in the CTP, it's not RTM'd yet. Having said that, you can extend LINQ to create your own adapters and create LINQ-enabled data sources for any kind of databases. Quick recap of how LINQ to SQL actually runs. So you have a LINQ query in your application, it's converted into an equivalent SQL query by the LINQ to SQL layer. SQL Server or your database returns the rows or records, which are again converted into objects. You can manipulate these objects or deal with these objects just like any other object in your code, and then call a submit changes method, which would generate the insert, update or delete query for that particular change and run it on the database, thereby giving you complete CRUD functionality. How do the artifacts in LINQ map to the SQL artifacts? So databases become your data context, tables and views become your classes, columns and relationships become fields and properties, and stored procedures become your methods inside the data context. Again, I don't need to reiterate this. It gives you a lot of benefits because now you are dealing with strongly typed data. You can run your queries on top of strongly typed data rather than just embedding SQL statements as text. You can store the mappings in an external file, so that if you have to change them at runtime, if you want your DBML to be totally separate from the mappings, you can do that. You can persist the changes, implement change tracking or implement updates through SQL or stored procedures. This is the last slide by far. I just want to capture one very important thing. Don't confuse LINQ with language enhancements and LINQ to SQL. There are 3 different things. Language enhancements, nothing to do with LINQ. You can use those language enhancements in your code as it is without even using LINQ. LINQ is built on top of these language enhancements. You can use the inbuilt LINQ functions or the LINQ libraries, or you can extend the LINQ APIs to create something like LINQ to SharePoint, LINQ to RSS, LINQ to file system. That's what is LINQ enabled data sources. So 3 layers: language, LINQ and LINQ enabled data sources. I'm done. Resources are fairly simple to find. MSDN, LINQ. There's lots of data. There is one very good article by Anders Halesberg on the LINQ project. Very strongly recommend you to read that because that's a very non-technical article, but it gives you a very good understanding of where this whole philosophy of LINQ came from and what is the problem space we are trying to solve with LINQ. That's it from me. Thank you so much. I will be available here. Any questions, any doubts, please find me and I'll be glad to answer them. Thank you.
Thank you so much, Bijoy. Just